this class we are going to see about the drift current density of semiconductor. So this is the formula for the current density. Generally J is equal to sigma into E, where sigma is the conductivity and E is the electric field generated due to the applied voltage. So in general in semiconductor we used to notate N as a free electron and P as the hole. Then similar to by using these two notations, N for electron and P for charge, whole charges, we can define the mobility of the both. That is, for mobility of free electron, that is mu N, and for the mobility of holes, it is mu P. Right? The suffix term indicate the type of the polar charge carrier, whether it is electron as negative and for N as P as the hole. The drift current density for free electrons. So according to that notation, so if you rewrite this general equation, J is equal to sigma into E, and substituting the sigma value, so Jn equal to N into mu N QE, because we know that sigma is equal to N mu into Q. So if we are writing the current density for free electron, that's why we have put the suffix of N here. So Jn is equal to N into mu N QE. Similarly, for the drift current density of the hole, we have to replace this N by P as a suffix. So Jp is equal to P mu P Q into E. So if you add these two for the free electrons on the holes, you will be getting the total current density J, which is equal to the summation of Jn and Jp, that is equal to N mu N plus P into mu P and QE. Since QE is constant, that is the common for both the term, we have taken the outside. So here this is the one equation, and here we have another equation, that is generally J is equal to sigma into E. So when comparing this equation with this equation, so the electric field on both sides will get cancelled. So the remaining for the current density, the total current density J is equal to N mu N plus P mu P into QE. So by comparing that one, we can able to write the conductivity expressions also. Sigma is equal to this one, right? Because J is equal to sigma into E. So if you substitute J is equal to sigma into E here, you will be getting this one. So this is a general equation for conductivity. So by using this equation, we can able to understand that the conductivity of the semiconductor is purely depending upon the three factors. One is the value N and P, where N is the concentration of electron and P is the concentration of hole, and mu N and mu P is the mobility of electron and mobility of hole, and Q is the charge of the electron, right? So this is about the intrinsic semiconductor. And intrinsic semiconductor concentration. So for intrinsic semiconductor at any room temperature, the free electrons and holes are equal in numbers. We know that. That's why it is called as the intrinsic active semiconductor. So this concentration is called as intrinsic concentration. Therefore, the concentration of electron N is equal to concentration of hole P is equal to, in general it is represented as Ni, where Ni is the concentration for intrinsic semiconductor. So if you substitute N is equal to P is equal to Ni in the previous equation, we have derived the conductivity of the semiconductor in general here. So if I substitute N is equal to P is equal to Ni, so that will be a common number, so I can take outside. So the remaining is sigma I is equal to Ni mu N mu P plus Q. So this is the expression for the conductivity of the intrinsic semiconductor. So here both Ni and sigma depends upon the temperature, and we know the thermal generation. So as temperature increases, so Ni increases and the conductivity is increases, and thereby the resistivity rho I, that is equal to the reciprocal of 1 by sigma I, that is equal to decreases, right? So here, since the conductivity and the resistivity is depending upon the temperature because of the thermal generation, we have equated the concentration of the intrinsic semiconductor in terms of the temperature by using this equation, that is equal to Ni is equal to Vt whole power 3 by 2 e power minus E G naught divided by 2 kT, where B is a Boltzmann constant and T is the absolute temperature in Kelvin, and E G naught, it is a forbidden energy gap at absolute room temperature, and K is the Boltzmann constant, that is equal to 8.62 in 10 power minus 5. Right? Thank you.